Okay, so do you want the whole thing? Part of it? What's the story? This is not it?
No, I didn't have a problem with this. I remember the next one. By mistake in the page.
You want to see this one, yeah?
I'm not sure.
Okay, fine. Is this the one you want to see?
Sorry, never mind.
No, let's go. Please do it. He needs it.
Right, fine. Which part? A, B, C, or all of it? C. Okay. So dy dx equals x over log y. Okay. So dy dx equals x over log y. So I get log y dy equals x dx. Yeah? Right, how do I do the one on the left? Yeah. So what? Yeah, so I put 1 here and then use my by parts. So, that's wrong. F derivative, G derivative. So that's log y. So that's 1 over y. That's 1, so that's y. Yeah. So the rule is this is fg you know what, I'm going to skip a couple of steps. I know what the answer is. After I use the rule and simplify it, the answer would be y log y minus y. Equal to a half x squared plus c. And that's it.
Can I ask something? It's just that they brought an integration question in a differentiation part. That's why...
Oh, wait, hang on a second. Wait. Sorry. I've just realized something. Sorry. We haven't done this chapter yet. So rewind. So it is perfectly fine that you can't do it because we haven't done it yet. Sorry, as I was doing this, I realized, wait a second, I've never shown you this before. So forget about that. No, we didn't.
No, we didn't, but
we didn't. That hasn't.
Watch the video in order to learn this.
Good for you. That question there is actually page 78. If you look at 78.
Why did I bring it?
No, forget about it. I don't know. They just mix things up. Just forget about it. Yes. Yeah, that part of it is. Just let's forget about it, okay? We haven't done this yet, so let's forget about it.
So what is he doing? Page 36. 14.
Right, the next one is 36, yeah? 14? Alright. Yes, yeah, oh, yes, okay. Right. 14 now. Page 14 is what MB wants next. So which part?
The last part, B.
But then I feel like I kind of have to do the whole thing to get to it. Alright. So what I need you to do is call out this equation to me now. Do you have it?
Yeah.
Alright, so what was it?
X squared plus y squared.
Yeah.
Equals x plus 1 times y plus 2.
Okay. So here, they probably want the derivative. Yeah. So the derivative here is 2x plus 2y dy dx. And now here I need the product rule. No product rule? Yeah. So here this is 1 y plus 2 plus x plus 1 times dy dx. Yeah? Now, I have to rearrange this. But when I rearrange it, I get this. 2y minus x minus 1 dy dx equals y plus 2 minus 2x minus 2y when I rearrange things. So I can get now dy dx equals minus 2x minus y plus 2 over minus x plus 2y minus 1. And I think that answers the first part. What? What did I do wrong?
Replace the plus
What's a plus?
the y.
Are you sure?
Are you doing it as a question to answer?
Y minus 2y is minus y. What did I do wrong? Did I do anything wrong? Oh, sorry. This isn't here. No. Shh. Just I need 10 seconds of silence, okay? So on the right here I should have y plus 2 minus 2x. And then on the left I should have 2y minus x minus 1. So up the top here it should have read as minus 2x plus y plus 2. Okay. Now what do they ask next? They say the curve cuts the y-axis at 2 points. That's great. Find these points.
We don't have to do this part if you want to just move to D.
I'll do it for fun. And entertain me. So the next part is it cuts the y-axis at 2 points. So if it cuts the y-axis at 2 points, how do I find it? Yeah, just make x equal to 0. So if I make x equal to 0, I'll get y squared equals y plus 2. So y squared minus y minus 2 equals 0. So I have my 2 here. That'll be a y minus 2, y plus 1. So I get two answers. 2 and minus 1 for the y. And what were the x's? 0 and of course 0. So that's the answer for the second part now. They're the two places where it crosses the y-axis. It crosses here or here. They're the two crossing points, intersection points. Alright, so that's the second part done. And the third part now. Calculate the gradient at these 2 points. So I do need to find now the slope. So I have my x and y. So the first one is 0, 2. So if I put in the first one 0, 2, I'd get 4 over 3. And then what was my other point? 0 minus 1. So the x is gone. That would be 1. Hang on, hold on there. Let me think. 1 over minus 3. So minus a third. There we go. And that's the next part done. Yeah? Got that? Now the final part, find the value at two other points. At two other points, C and D, the curve is parallel to the y-axis. Find the value of y at these points. Now, is parallel to the y-axis. So what type of slope does a vertical line have? Infinite slope. Which basically means here the denominator is 0. So they want to know where is the slope infinite? Here is where it's infinite. When this equals 0. However, this is not enough information to find x or y. So what do we do next? Yeah, you can use the original equation as well as a second equation. X, what was it? X squared plus y squared bracket x plus 1 y plus 2. Now I think the easiest thing would be if I take this Well, actually, firstly, does he want the points or does he just want the x and the y? Find the y. So because he just wants the y, that means I can get rid of the x and solve for y. So if I take this x here to the other side, I get x equal to that. I can substitute it into this. So instead of x squared, I get 2y minus 1 squared plus y squared equals 2y minus 1 plus 1 times y plus 2. This will be 4y squared minus 4y plus 1 plus y squared equals, well, they cancel, 4y squared plus 4y. That cancels that. So I got y squared minus 8y plus 1 equals 0. What? I have 2y squareds, do I? Where? Here. It's not 4. That's 2, sorry. So that doesn't cancel then. Oh well. So if I take everything to the left, then I get, that's 5y squared minus 2y squared, 3y squared minus 8y plus 1 equals 0. Yeah?
On the left it's 4y squared, and on the right it's 2y squared.
Yeah, so it would be 5y squared minus 2y squared.
Right.
It's 3y squared.
Oh.
It's okay, isn't
Because
it?
I left the y squared.
Well, it has to be 1 and 1, and it has to be minus and minus, and it has to be y and y, and it has to be 3. So this doesn't, that's not right, is it? So does it have, is it a decimal answer? It must be a decimal answer. What do you get when you use the formula, or in other words, the calculator? What does it tell you here? I mean, it does have 2 roots, because delta is 64 minus 12, which is positive. So it does have 2 roots. But they're going to be decimals. Oh well. Not everything in life can work out nicely. So what are the 2 y values here?
2.54 and
0.13.
0.13.
Okay, there you go. I feel like a derived graph is in order now. So we'll graph this and we'll see if this tangent is vertical at these heights. Alright, so just get your next question ready that you need from this revision book, please. X squared plus y squared equals x plus 1, y plus 2. Shh. Now, what were my 2 y values? What was the first one? Guys, focus up here. What was my first one? 2.54. Look up, Luke. So you can see here, there's 2.54. So there's two heights at 2.54. We didn't work out the x value, but I can tell you if you work it out, it's more likely to give you an answer of over here. Because I can see if I draw the tangent here, you see it is vertical. Where else is it vertical? Well, about here. And that's it actually, isn't it? It's just here and here. So here it's vertical at about a height of 2.5. And here it's vertical at a height of nearly 0. Which you see matches up with my decimal. So I know that this answer is right from the graph. And notice the shape is an oval shape. But anyway, I wanted to show you. So it's good that you can see vertical tangents here. By the way, what heights would be the tangents which are parallel to the x-axis? I'd say about here actually, -1 and 3.5 or whatever. Alright, that's good. What's the next question now? Which page? 36. The whole thing? Part of it? Okay, so just give me this equation, call it out to me. Do you have it written down? Yep, okay, so hang on. Right. 3 sine y plus 4 cos y
equals
xy plus x squared. And question the first is what?
Show that the curve crosses the x-axis when x is 2 or minus 2.
So what I want to show is that it crosses the x-axis at plus or minus 2. How could I show it crosses the x-axis at plus or minus 2? Yeah, well, one way you could do it is you could show that minus 2, 0 and 2, 0 is on this curve. Because these are the points where it crosses the x-axis at minus 2 and 2. So let's put in the first one. You'd get 3 sine 0 plus 4 cos 0 equals 0 plus 4. Well, sine 0 is 0, 0 is 0, cos 0 is 1, so you'd end up with 4 equals 4, which is true. So we confirmed that this point is on the curve. Let's check the second one. 3 sine 0 plus 4 cos 0 equals 0 plus 4. Sine 0 is 0, cos 0 is 1, 0 is 0, 4 equals 4. True. So we've confirmed that this point is also on the curve. So we've shown that these points are on the curve, i.e. the point crosses the x-axis at plus and minus 2. So that's the A part. I don't know if that was a problem or if you figured that out yourself. Good, okay. So what's the B part asking you now? Find the derivative. Yes, okay. So if I go up here, the derivative is 3 cos y dy dx minus 4 sine y dy dx equals 1y plus x1 dy dx plus 2x. I need the product rule here. So after some rearranging, you'll end up with dy dx equals y plus 2x plus 4 sine y over 3 cos y plus whoa ever wait y plus 2x. It's just y plus 2. Just y plus 2x on the top. Sorry, and then you get 3 cos y minus 4 sine y minus x on the bottom. Would part C be by any chance to calculate at the 2 points? Yeah, forget about that.
That is my problem.
Part C?
Yeah, because sub in the points. I don't know, because when I sub in like for y at the bottom like cos, then I don't know why, but sometimes the y like is disregarded and sometimes they add like minus 4 sin 0 minus the point.
I'm not sure what you're saying. Let me put in the point and see what happens. So, what was the first point then? Dy dx, what was the first point? minus 2, 0, was it?
Yeah.
So if I put in minus 2, 0, well, the y is 0, and it's 0 for both, isn't it? So that would mean that this piece always goes, and this piece always goes, and cos y, or cos 0? 0. So it's like the y is not important. So I have minus 4 over 3 minus minus 2. So 3 plus 2, 5. And at the second one, 2, 0, I get 4 over 1. So I get 4. Yeah?
Because I tried it a different year, and then the question is something like this, but it turns out different. Can I tell you the?
Yeah, we can look at that in a sec. I just want to make sure that we're finished with this one. Do you need to see the D part?
No, just right?
Is the D part find the tangent at each of these points?
Yeah.
It's where the
Fine. I mean, you know what's the equation of a tangent? Y equals mx plus c. What's the m? Minus 4 over 5. And how do you find the c? Use a point. And what's the point? Minus 2, 0. So, I mean, it's completely standard. You find two tangent lines, no problem, and then you solve them together using one of your many methods. Elimination, substitution, matrix, whatever. There's absolutely nothing new in that question that you couldn't have done in semester 1. So we'll leave that one there. So what was your next one then, Luke?
It's also a question C problem.
Yeah.
dy dx.
What year though? What page? Well, if you don't have it, I can write it down if you know what it is.
Version 4, 2012.
Oh, don't tell me this. Version 4, 2012. What year am I on? What is this?
Page
Page
29.
29.
Yeah?
So the dy dx at this point is 3y minus 14x. Because I'm at C, stuck at C.
Ah.
It is
But the y is 0. Because this is where... Yeah.
y is 0.
So why are you stuck? What's the problem? Why are you stuck? You have x and y, don't you? No. Use your English. So you have x and y, don't you?
Yes.
So what's your first point?
The first point is 1 and 0.
Good. And the second point is minus 1 and 0. And if you put that in, what goes so wrong?
I get the answers that differ from the answer page. And every time I put it into like Wolfram alpha, I put it to derive, it comes out the same answer, like
The same as what? Yours or the marking scheme?
the marking scheme.
So you're doing something wrong,
Yes.
and you don't know what it is.
Yes.
Fine. So I'll do this one. So just call out this equation for me, and you just want to do. I'll just do the B part, okay? Right. So I'll just ask, okay? Your calculator is in radian mode, right?
It doesn't matter because it's always
No.
Problem solved.
No, but I did it manually and I still couldn't.
But your calculator should be in radian mode. All right, fine, whatever. We'll do it. All right. What's the equation?
6 sine 1
6.
sine 1
Yeah.
minus 7 sine 1
Yeah.
plus 3xy
Equals.
3xy
Yeah.
minus 7x squared.
All right. So this will be 6 cos y dy dx plus 7 sine y dy dx equals 3y plus 3x dy dx minus 14x. Oui? All right. Dy dx equals... Shh. Now, look, I'm trying to do a couple of steps in my head, so just be quiet. Let me think about this. So I have here 6 cos y plus 7 sine y minus 3x 3y minus 14x. Now, what's my first point? 1 and 0. So if I put in x is 1 and y is 0, I'd get, well, y 0 is for both of them, isn't it? So that's always gone. That's always gone. That's always 1. So you'd be left with minus 14 over 6 minus 3, which is 3. Did you say cos 0 is 0? Yeah, there you go. And then if I put this one in, it'll be 14 over 9. By the way, how many marks for that? Because what I just did there was the derivative and the substitution. So I think I did part A and B, was it?
Yeah.
So 8 marks.
Yeah.
See? I like this question. It's good for the exam. Yes? What else now? 64 next, yeah? Okay. Well, before I jump down to 64, are there any questions between 36 and 64? No? Am I going straight to 64? What? Is he distracting you? Do you want me to kick him out for you?
He's not talking about me. He's talking about time. That's what I asked him.
Why is it when there's trouble you're always around? Is there anything else before 64? No, so we got to 64. So this is your question, is it? So what part, or is it the whole thing?
I don't understand first the explanation, everything.
So pretty much the whole question then.
Yeah, the way they said it.
Oh, right, I got the idea, the whole thing. Right, got it.
Yeah. They said 2 points A and B.
Yes, okay.
On
It's okay. Teacher will take care of you now. Right, now if I look at this one, a curve C has equation as follows. There are 2 points, A and B, on C at which dy dx equals 3. So if I read that, what I understand from it is that there are 2 places where the slope, where the gradient, where the slope of the tangent is 3.
They said on C.
Ah, but that's the curve. The curve is called C. Yes, no, I understand. This caused confusion last time people did this. I understand. The y-coordinate of A is positive and the y-coordinate of B is negative. So this is quite similar to a problem in the worksheet. Unfortunately, they don't tell you the x and the y. They tell you what the dy dx is. Whereas normally, or at least recently, they give you the x and y and you have to find dy dx. This is literally the reverse. They give you dy dx and you have to find x and y. Which sounds like it shouldn't be too difficult, but actually is much more difficult, and you can see that by the fact that there's 6 marks for it. Okay, so let's have a look at this one. I just need someone to write this equation down so they can read it back to me, or do you have it in front of you? Yeah? Alright, so what is the equation then? X squared
Plus 6xy minus y squared plus 8x plus 4y plus 32 equals 0.
Right, so first things first, let's get dy dx. So 2x plus 6y plus 6x dy dx minus 2y dy dx plus 8 plus 4 dy dx equal 0. So dy dx equals 6x minus 2y plus 4 in the denominator minus 2x minus 6y minus 8 in the numerator. Yes? Now, I'll divide everything by... I'm trying to think, should I use 2 or minus 2? Let's go with 2. So minus x minus 3y minus 4 over 3x minus y plus 2. Now they tell me that dy dx is equal to 3. So that means this whole thing here is equal to 3. So I get minus x minus 3y minus 4 equals 3x minus y plus 2. What I did was I said this is equal to 3, and I just brought the denominator up. When I expand, I'll get on the right 9x plus x, 10x, minus 3y. Now this is really helpful, because here I get minus 3y, but here I have minus 3y, and they cancel. And that's so helpful, so helpful, because now there's only one unknown. Here I get 6, and here I have minus 4. That's equal to 10. Plus 10. So then x equals minus 1.
Is there any scenarios where you don't cancel?
Oh yes, there is. And what you have then is one linear and one quadratic. So you were no way guaranteed that was to happen. No way guaranteed. In fact, I think they deliberately did that to make it a little easier.
Yeah, because I know the past question will all cancel.
Yes, but that's just them being generous. Okay? Yes. Now, what I do next? Well, I have the x, so how can I find the y? Yes, sub it back in. Whoops. Sub it back into this one here. So x is minus 1 now. So here I get 1 minus 6y minus y squared. I'll scroll down in a minute. Minus 8 plus 4y plus 22 equals 0. So I get y squared minus 6y plus 4y is minus 2y. Take it to the right, 2y. 1 plus 22 is 23. Take it to the right. 23, and then minus 8, isn't it? So 15. And take it to the right, minus 15. 5 and 3 seem to be it. Y minus 2, y minus... What am I saying? Sorry. Y minus 5, y minus 3. So y equals 3 or 5. So I have my answers. Minus 1, 3. That's the A. And then the B is minus 1, 5. What? Yeah, one of these is a plus, sorry. Plus here, isn't it? Makes that one the minus. Trickier, but not outrageously difficult. Yep. Understanding is key to doing a question, yes. Now, that's probably the A part. Find the equation of the tangent at A. Well, what's the slope at A? 3. And what is the point A? Minus 1, 3. So could you find the tangent? Easy peasy. Find the normal at B. What's the slope of the normal at B? Minus 1 over 3. And the point is minus 1, minus 5. Could you find the normal? Again, easy peasy. And then finally, find where the tangent and normal intersect. Yeah. So look, 4, 5, 6, 7, 9 marks I consider to be 9 marks that are, guaranteed, because you have this from semester 1. The difficulty here was the 6 marks of number 1. But let me give you a very valuable lesson, a very, very important lesson. You need to be listening carefully. If you were in the exam, and if you were doing this, and if you were reading this, suppose you were thinking to yourself, oh, that's really easy, I can do this. That's really easy, I can do this. That's really easy, I can do this. But then you can't do this part, and you might think, oh, great, Now I can't do the question because I can't find my A and B to use here. No. What you would do is you make up some answer here for A and B. Literally make up an answer and use that answer for 2, 3 and 4. You do not lose marks twice. So of course if you make up an answer for part 1 because you can't do it, then I'll give you 0 out of 6. This is not ideal. However, it means you still get 9 out of 9 here. So instead of throwing away 15 marks because you can't do the first part, you instead throw away 6 marks and gain 9. Now this is what I mean by exam strategy, okay? These are the things you need to know. Because sometimes people feel, I can't do this, that means the rest of the question I have to leave it. Not the case. You can still pick up valuable marks. And here, valuable marks actually equal to 9% of the exam. Okay? Really, really valuable lesson there, okay? I think this is a good demonstration of how a little bit of exam strategy, a little bit of just keeping your head cool in the exam can really pay off. Because, as you know, 9% could definitely be the difference between grades. Okay? What else now do we have to see from those revision questions? So to summarize, there was only a part C that could not be done, and that's fine because we haven't done that chapter yet. Although part of it contains the integration by parts as well. So that was a little bit difficult, but still, when I actually show you how to do it, you can see it didn't actually take me long to do when I accidentally did it. So I would consider question 1 in the exam at this point to be an okay question. Yes. Question 1 is one of the questions I recommend that you do in the exam for sure. The way I think about it is there are 3 questions in the exam you should definitely do. And then really the choice comes down to what's your 4th question going to be. So everybody is doing statistics. I don't care who you are. You're doing statistics, and everybody is doing question 1, which is what we were doing today, the differentiation. And everybody should do question 2, which is the one about the functions. The 4th question is entirely up to you. It's going to be difficult to pick because they were the 3 easier topics. You're going to be stuck with, there's no way to avoid it. Your 4th question is going to be something difficult. And the question really is, which is the least difficult for you? So maybe it's the integration, that's what we're doing now. Maybe it's the vectors, that's what we'll do later, you know? Okay, so before you go, let me just see if that video is working, okay, on YouTube. When did you say processing?
Last night, 11 p.m.
Oh, okay, we use the 11 p.m.
11 p.m.
What function is